Hello, you guys. We are on lesson 18, session 2. We are developing writing and solving equations with two or more addends. When we see two or more addends, those are like terms. If you remember what like terms are, oh, that's some ugly writing. Let me fix it. If you remember what like terms are numbers with the same letter. You could put those together, and numbers without letters can also be put together. So we have here a problem, a word problem, where we need to use this word problem to figure out what the equation is, and we need to solve this equation. So here we have 4 times as many bricks for the arch. Oh, this is part of the problem. And it looks like it's like a stage or something. Let's see. Noah designs a set for a school theater production. Right there. Looks really nice. He has 150 cardboard box or bricks. He has 150 cardboard bricks. There you go. We're probably going to need to use that, but let's keep reading. I'll actually write that down. Has 150 bricks. He uses some of the bricks to make a chimney. Okay. I'm guessing that's going to be important. Let's keep reading. He uses it to make a chimney. To make an arch, he needs to use 4 times as many bricks as he uses for the chimney. Oh, yep, this is this part of the equation. He uses some of the bricks to make a chimney. Notice they say he needs to use 4 times as many bricks for the chimney. Chimney is a variable because we don't know how many the chimney is. It never mentions anything about the chimney. So chimney is the letter X. Chimney is the letter X. There you go. And then that means that the arch is something else. To make an arch, he needs to use 4 times as many bricks as he used for the chimney. So since the chimney is the X, we're going to put 4 times X. 4X, like that. There you go. Look at that. Look at that. He has this many bricks. He needs X amount for the chimney and 4X amount for the arch. He also saves 15 bricks in case some get crushed. So he wants to save 15 bricks. Let's honestly save that already. He has 150 and wants to save 15 bricks. Yeah. Let's honestly do that already. 150 minus 15, I believe it's 135. Yeah, it is. 135 bricks. There you go. He saves 15 bricks. And then lastly, how many cardboard bricks can he use to make the arch? So we need to find out how much the arch is right here. How much for the arch? So this is already an equation waiting to happen. The amount of bricks for the chimney and the amount in bricks for the arch should equal 135 bricks. And when we talked about with 2 or more addends, we're talking about like terms again. So we're going to be combining stuff here. So we're going to combine these two together because they both have an x. This is a 1x. So 1x plus 4x is 5x. And bring down the equal and bring down the 135. There you go. Now for step 2, let's solve our equation. 5, we are multiplying by x equals 135. I'm going to rewrite this with parentheses instead. Equals 135. So what number times 5 is going to equal 135? And honestly, I have no idea. So 135, I'm going to use long division. 135 divided by 5. Let's see, 5 goes into 13 twice. 10, subtract, bring down the 5. 5 goes into 35, 7 times. 0. So 27. That means that 5 times 27 equals 135. That means that our x is equal to 27. So when we're working on this, how many cardboard bricks for the Let me make sure. For the arch, how many for the arch? We are saying, oh, okay, so for the chimney, we have x. We know what x is. It's right here. It's equal to 27. And then we have the arch. Uh, 4x, which is just 4 times 27. Yeah, 4 times 27. And if we solve that out, 27 times 4, 8, 9, 10, 108. There you go. It's 108. So we need 108 bricks. Let me write it in green. What was the person's name again? Noah. Noah needs 108 bricks to make an arch. And I want a full sentence, as always. How would you explain what the problem is asking in your own words? Well, in your own words, the problem is asking, pause it to see if you can do this too. The problem is asking, how many bricks do we need to make, the arch? We have chimney bricks and arch bricks. So we're making an equation so that we can solve for how many for the amount for the arch. We solve for the x and we plugged it back in to make sure we find out. Okay. And I'm going to change this for arch. There you go. Awesome. Now we have here in the connect it. Describe 2 ways you could solve the equation. 2x plus 12 equals 8. There's 2 ways. 2x plus 12 equals 8. 2x plus 12 equals 8. Okay. There's 2 ways you can think about this. Well, first, pause the video, see if you can do it on your own, and then we'll see from there. I notice what number plus 12, we have to remember though, this is a 2x. What number plus 12 equals 8? Well, I know that they have to be different, so we're going to subtract for sure. So they have to be different signs, so it has to be negative. So if I do 12 minus 8, it'll give me 4. So I need to add negative 4 to this. Yeah, negative 4, because 12 minus 4, let me make sure. 12 minus 4 is, carry the 1, 5, 6, 7, 8, 9, 10, 11, 12, 8. Yeah, is 8. So 12 minus 4 is 8. And since they're different signs, you do subtract, and it does give you 8. But remember, this was a 2x. 2x has to equal negative 4. So how do we make that 2x equal to negative 4? Well, 2 times negative 2 is 4. So x would equal negative 2. So if I were to plug in, look at that. If I were to plug in negative 2 over here, 2 times negative 2 would be negative 4. I would add 12 to that, and it would give me 8. Look at that. Perfect. So x is equal to negative 2. This is algebraically. Algebraic method. Yeah, algebraic method. For this one, you can also think about this as arithmetically. Oh, wait, no, this is arithmetic. Oops. This is the arithmetic. The arithmetic method. You're using logic. Oh, what number plus 12 is this? What number times this will give me this? 2x plus what? You can also solve this algebraically. You can also think about this kind of like in the hanger diagram, remember? oh, I can cancel one box on each side because and then there's one left over so that it stays balanced, as long as you balance it. So I noticed that in the hanger diagram, I have 2x, and then I have a bunch of 12s, and then an 8 here. So we need to leave the variable on the left side alone. So we need to remove some boxes. So notice that 12 is bigger than 8, but we're still removing some boxes. So all these boxes, we're going to subtract them to the other side. So minus 12 on this side. And notice that we're going to keep those negative boxes, negative 4 boxes. Negative 4 equals just be 0 because we're canceling out the boxes from the hanger diagram. And then from here, you could just say, oh, 2 times what is equal to negative 2? It's negative 2. This is algebraically with the hanger diagram. There you go. This is using the hanger diagram. Or how you should think about it whenever we're solving it algebraically, hanger diagram. Well, y'all, you're going to write this, not me. So your 2 ways to solve the equation, here's your sentence starters. Go ahead and write it. Remember, you can always pause the video, rewind, and then you have 10 problems to do in your practice. You're solving problems that look just like this, where you most likely will be combining like terms. Well, guys, have a good one. And if you need help, I got you. Bye-bye.